Okay, it looks like our numbers have kind of stabilized, so I'm going to get going. And welcome you to our second day. We're pleased that you decided to join us again. Today in our webinar portion, we'll look at the pilot project we undertook as part of our second grant. We can see what modeling conservation data looks like in real life with some of the challenges and the results so far. Let's see. I will start by sharing with you the background of the pilot and what our overall aims have been. Then we'll hear from Alberto Campagnolo and Lieu, who did much of the technical work in modeling the data from the participating pilot members. Then Thanasis will walk us through the results of that in ResearchSpace. When we break off to our practicum sessions, we'll be discussing modeling in a slightly different way from yesterday. We talked about this a little bit at the end. Today we'll look at levels or signposting information, where instead of modeling complete contents of documentation, limited information is selected and made available to point researchers to fuller information sources. So back to the pilot. When we began planning for our second phase and grant proposal to the UK's Arts and Humanities Research Council, we had a lot of work we wanted to continue. We wanted to work on developing our terminology and modeling resources. We were also interested in educational outreach and policy. It also seemed necessary to start to try things out, to see if what we had been developing resources for would actually work. Could we take real conservation treatment reports from different institutions and model them? Could we ask research questions across the data sets and get back meaningful answers? We approached 3 institutions who had been active in our consortium and also included my own Stanford libraries. So altogether, we were the Bodleian Library, the Library of Congress, the National Archives UK, and Stanford Libraries. All agreed to participate and contribute records. We decided among ourselves to pick one of the most common treatments that book conservators do, board reattachment, since it would be easy to find treatment reports for that, more easy than perhaps anything else in a book lab. Another appealing aspect of looking at board reattachment was the range of treatment options possible. Over the past 20 to 30 years, new techniques have been developed to reattach boards, so we thought it was likely we would have a high range of techniques to represent. Each participant agreed to provide between 30 and 50 records from over 40 to 50 years of conservation documentation, depending on how long their labs had been in existence and how long they had records for. In addition to this, with the help of Thanasis, we developed the following research questions. And they are, what is the history of board reattachment techniques over the last 50 years? Can we identify the periods that each repair material was being used? How do detached boards relate to other book condition types? For example, spine reattachments or repairs. And what types of records are needed to infer the impact of repairs to the study or history of books? So with these questions in mind, participating labs identified and gathered reports and records for the pilot. They prepared terminology spreadsheets so that all terms had a unique identifier, and many had agreed on a concept definition or scope note from a terminology source available as linked open data. Most often this was the Getty's AAT. In some cases, they prepared them to be structured data where they weren't already. This was the case for our records at Stanford. And in some cases, we modeled the data or worked with Alberto so that he could do that. Then the records were uploaded to ResearchSpace, and Thanasis will tell you about that. So now I'm going to stop my screen share and hand over to Alberto, who will start us off in our discussion of the actual modeling.
Okay, so what I'm going to talk about is just a very short introduction on how we went about to model this conservation data that we got from the partners and to put that into a CDOC CRM compliant format. So the first thing is that I started working on the data set that was given from different partners, and these were pretty different from one another. I had to work on the data set from the Library of Congress, the National Archives in London, and the Bodleian Libraries in Oxford. The data set from the Bodleian Library was a set of records, handwritten, quite complex, varied from tick boxes to full-on reports written on Word documents. Some of this data had like drawings to assess better how things were put into the object. So quite a variety of different style of information there in these records, and all of this, of course, was all in a format that was not ingestible directly from the computer. Then the records from the Library of Congress, as I was given them, was actually a lot more simple, and they were in the form of an Excel spreadsheet with different fields and different sheets that gave different information about what happened to the object at different stages, what material were used, and what treatments happened. Similarly, the data set from National Archives was given to me as a spreadsheet. And again, this format was very similar to the Library of Congress. So we have like fields to tell us what happened to the object, what kind of treatments happened, and what kind of materials were used over the whole treatment. So how do we turn all this different kind of information into something that we can ingest and use via computer to transform this into an RDF format compliant to the CDOC CRM? What we opted to do was to create an XML file that could represent this data in a more structured way. So I sat down and wrote up an XML schema that could accommodate all the different kind of information that I had in different data sets. Starting off from the Bodleian records, because those were the most complex that I had. So the plan was, we have these records, we model them into an interim model, XML model, and then from this model, we can map onto the CDOC and bring down the CDOC to our domain through links to the AAT or the language of bindings or other terminology and thesauri that were online. So how did I went about to do this process? So one tool that I used that helped me to navigate the CDOC CRM as I was trying to model my data into the CDOC was the 3M and Mapping Memory Manager. And I used it mostly just to guide me through the process. So to see if I have an MN object, what kind of properties and other entities I can link it to, so that I was sure that I wasn't making mistakes according to the CDOC model overall. I didn't use the tool to then export this into RDF because I prefer to use a different methodology that I had used in the past. So from the XML documents that I had representing all the different data sets, I wrote an XSLT script, which is basically just a style sheet that takes information from the XML records and outputs it into a different format. In this case, it was the CDOC compliant RDF XML-based format. And as Kristen mentioned, then the partners worked, as I was working on the modeling, the partners were working on mapping all the different kind of terms and terminology that they use in their records into AAT, language of bindings, or other thesauri online. So in the end, the modeling process was in two parts. On the one part, you have how I was transforming the XML records into RDF to map these to the CDOC. And then for all the different terms that have been used into the record, these were mapped to the AAT and language of binding. And most importantly, each one of these was given a unique identifier that was used consistently through from the mapping to the AAT to working on the model. So we had this unique identifier that was able to link this term or material or other things that we could map to Tesore and use that uniquely throughout the whole process. Then, as we will see later on, everything was ingested into ResearchSpace. And through there, we can actually start to play and see what data we ended up offering to the tool, which is actually quite amazed because as you saw, I was working all in XML and RDF XML. So actually trying to see the data eventually is actually quite good and sort of satisfying. Lesson learned. I think the major lesson that I learned through the process is that as I was mapping and creating my XML schema, I ended up working on a slightly more complex model than I should have. Because as you see here in the representation of the schema, what I ended up with was a treatment record that had split into 3 different fields, let's say, the description of the object, the condition, and the treatment. Now, XML works in a tree-like format, or it's like on a family. So at the very top, at the root of the document, you have your parent or grandparent, and then you go down to the children, the grandchild, the siblings, and all that. So everything is connected through this tree-like structure. So what I ended up with was actually having basically 3 parallel tree-like structures, one for the description, one for the condition, one for the treatment, that were a little bit redundant maybe, and made the mapping to the CDoc a little bit more complex, because I had to make sure that what was mentioned in one was corresponding to the one to the, for example, something happened to the sewing support on the description of the object, then had a condition and the treatment, and all of these had to be linked to the same sewing support. It's possible, but everything was a bit more complex. So what I think I should have done, and I would do in the future, is that I will only use one tree structure for the object. So looking at the object as the way in which we can enter into the data, and the way in which books are actually organized creates a very nice linear tree-like structure that follows the way in which the book was put together. So from putting the gatherings together, adding the end leaf sewing and all that down to the cover. And so this is actually a very nice, neat way in which the data can be modeled. And then on top of that, I would have mapped the condition and treatment all linked together into the one big tree-like structure for the description of the object. And I think this would have made everything a bit more neat and easier to then map and work with. And that's it for me. I'm going to pass it on to Ryan.
Thanks, Alberto. Everyone, I'm Ryan Lieu, the operations coordinator for Stanford's Conservation Lab. Thanks for joining us today. I joined the Linked Conservation Data Project here because I'm responsible for maintaining our documentation and working with Kristen to set our local digital practices. Here at Stanford, we have a mix of hand or typewritten hard copies from the first 3+ decades of our lab's activity and born digital electronic files since 2015. These are Word documents, though they weren't, they're meant for printing out. They weren't part of a database. And I'd spent the previous year before our pilot working on a side project to write text mining scripts to capture treatment data from those Word documents to save as XML records. This involved linking our many checkboxes with the values that they reflect. I think in the longest version of our form, we had about 300 checkboxes. And I was also capturing materials and adhesives and the treatments and locations where treatments happened, and the free text notes that conservators would also record. I'd also set up a new version of our treatment report template so that going forward, our Word documents would always save report data as XML records on the back end for eventual migration to a database. But the majority of our documentation resides in decades worth of treatment reports kept in vertical files. At the start of the project, Kristen identified a selection of 30 or so relevant treatments and scanned them to PDFs. So she went through and found board reattachments. And then we took that existing Word template I'd created for reporting and pared it down to only the fields relevant for answering the pilot research project questions. And Kristen used that template like a cataloging interface to review the PDFs she'd scanned and create XML data from the hard copy reports. So then we had XML data from those hard copies and section that was already XML from those Word documents since 2015. Our data then needed a bit more preparation so that it was in better shape for working with the CRM model. To do that, I worked with Alberto to align our data more closely to the model he was creating for data from the Bodleian and our collaborators because our existing XML data was rather flat. This meant thinking about the book as a hierarchy of components that have typical attributes that we identify and noted damage. And then also abstracting treatment into steps that occur in sequence, affecting certain components at specific places on the object while employing materials, adhesives, and techniques that we need to make note of. Once that hierarchy was defined, I used XML development software called Oxygen to create an XSLT file, which is a set of transformation instructions that would refine our XML data gleaned from the Word documents and created by Kristen by transforming it into a more friendly CRM, or a more CRM-friendly version of the XML. The great thing about this software is that it made batch work and the many revisions I had to do after we started looking at the linked data very easy once a transformation script was written. The software has detailed documentation and a very large user base. A lot of metadata specialists use it at many institutions. And in addition, there are lots of resources out there to learn XSLT, the transformation scripting language out there. And then with the updated XML records in that more CRM-friendly format, I used the same 3M memory mapping manager tool from Forth that Alberto talked about. But I built a full mapping from our XML to the CRM and used the tool to generate our linked data. This step is where I used the CRM much more directly to start generating linked data. After all of that preparation, our local data has meaning to us because it's ours, but it doesn't necessarily hold direct and immediate meaning to others. In 3M, the mapping we create is essentially a way of marking up our data with CRM classes and properties to add semantic meaning defined by the CRM ontology, which we use to create shared meaning with other similarly mapped data sets. So I am going to just show you very quickly how it works. In 3M, you mostly work in a set of tables that you map down different branches in your XML tree structure, like the one that Alberto was showing you. Here I think I've defined a component part of the object that's being conserved. So it might be, since we were talking about books, this might be referring to the spine linings or the boards, something like that. And I know that in my XML that is called a component. And I've already defined that component as a man-made object, E22 man-made object, and that's the class that I've assigned it. And then from there, each of the rows below, we find, let me zoom in a little bit. We find descendants from that component, and it's the things that I'm saying about that component. And here I'm describing the condition remarks that were made by the conservator. So the 3M tool is a powerful engine for transforming XML data because you preload your XML, it knows your XML tree for you, and then it also has all of your CRM classes and properties preloaded for you. So I just click, and from the dropdown, I can find the different aspects of my XML that I am mapping from. And I am going to choose this just randomly because I know it's a remark about condition that's in that part of the tree. And I will then go and select, over here is a property that connects to that man-made object that it defined above. And it's limited to only the properties that that we are allowed to connect to that class. And I'm gonna just type in cons to have it automatically filter to has condition. And then after a second, basically whenever it takes a second after doing each thing because it saves your work for you as you go, which is nice. And then after selecting that property, it has filtered down my list of available classes within range of that property to E3 condition state. And then once I've mapped all of the data that I want to map, I could use there are other sort of accompanying tools for doing large batches of transformation into linked data. Smaller data sets can be done in this interface too. Let's see, if that's it for there. I'm going to switch back to here. Are we back in my presentation? I can't tell what anyone can see.
Yes.
Okay. All right. The things that I learned from this project, I really wish I had started with a lot more practice in the CRM. I was quite behind. And if I had more time, I would have just sat down with a whiteboard and actually done some practice modeling with our data, basically the way that we're doing in the modeling exercises together over these last 2 days. I didn't do too much of it with my own data because I thought I was quite familiar with it, but I wasn't as familiar with the CRM. The CRM is really robust because it's meant to encompass basically anything and everything that you might need to document, but you don't need to know it all by heart, and you need not be afraid. I think to model for this project, I probably used 10% or less of the classes and properties actually available. And I know that's also because we really heavily curated our data to only be about board reattachments. If I was modeling a full treatment report, it would be more, depending on the complexity of the data and how detailed I want to map. But I found that I was using quite a lot of the same properties and classes over and over again because the XML data is pretty repetitive. And then one good example of a sticking point for me that took a while for me to wrap my head around, and I imagine this might be something for other people too, is the way that dates and time are handled in the CRM. I'm not going to go into a lot of detail because I would just humiliate myself in front of the other people in this workshop who are much better experts than I am. But to recap, I think most of us are probably more used to how we enter dates, like a year of publication or creation date, into one of our forms or into a library catalog or museum CMS as a string, a note string. So we input a year like 1799, or we might put in circa 1799 or not before 1799. But the CRM is designed for a lot more specificity. And instead, we say that an object has a time span, and the earliest possible date in that time span is the year 1799. January the 1st at 0 hours, 0 minutes, and 0 seconds. And here it's even down to the millisecond. And I probably just said that wrong, but that's my understanding of it. And this is just an example of how we need to shift our thinking from the relatively casual way that we're used to capturing a lot of our data to a different way of thinking to make our data more computer friendly. And then let's see. This, I think, would have been a lot easier to get started with modeling if we had a conservation-specific CRM profile, similar to the linked art model, which has been mentioned previously, and it's been developed or being developed for documenting art objects. Starting with a CRM or with a conservation-specific profile would, I think, make it a lot easier to train people with a less overwhelming subset of classes and properties, and the training could be designed with familiar data and use cases to provide domain-specific examples of how and when to use those properties and classes. And then finally, complex models and schemata will go through many, many revisions as you test them. I know Alberto said it was really exciting after working with the XML and different code for so long to actually see the data in ResearchSpace. For us, it was the same, but what we found as well is that once I could see our data as knowledge maps in ResearchSpace, which I think Thanasis will show you next, we found that Kristen and I will probably need to revisit our model and examine whether or not it is whether or not it fits earlier data as well as it fits more recent data, because I think we've built it with some bias towards more recent data, since there was modeling based on vocabulary, and vocabulary has changed over the decades. And that's it. Thank you. I'm going to hand it back to Kristen.
Well, I'm wondering, Thanasis, do we want to have questions for Ryan and Alberto now, or should we? I saw a couple hands raised during the presentations.
Why not? It's a good idea. Yeah.
Yeah. So if you have a question, could you put it in the Q&A? And then we can ask directly from the Q&A. Let's see. Let me start off with the one from the chat first, since that's the first one I saw. It's from Amy. Are there plans to build the CDOC CRM? Are there plans to build CDOC CRM into any of the repository software that already generates XML as part of packaging AIPs?
I'm not sure who should answer this question. I mean, I think as part of the project, we were always from the beginning trying to engage with companies that are producing software, and I think we're still trying to do so. Once we have a solution like a profile, we sort out the terminology and so on, it will be a lot easier to approach companies and say, and now can you please build this this export tool in your software so that people can just press a button and share their data. But it's a rather difficult question to answer at this stage, I think. I don't know if anyone else has any views.
Kristen, should we talk about Sinopia at all?
Sure. Do you want to say a quick word about Sinopia?
Yeah, as part of Stanford's efforts, not within conservation or preservation work, but for catalogers, and there is a consortium called LD4, Linked Data for Production, and they've developed cataloging software called Sinopia, which right now is built on BibFrame. But one of our hopes here, Kristen and I would like to develop a CRM profile for Sinopia. It is possible. However, we'd have to work with our software developers to make sure that it behaves properly as they develop Sinopia further and tailor it more towards cataloging, which is really exclusively descriptive cataloging and doesn't really handle a lot of the cases that we do. We'll just have to work with our software engineers in-house to make sure that it handles the CRM properly. But who knows? That is something that we are hoping to work towards.
Okay, let me ask a couple more of the questions that are coming up. This is a question for Alberto. And that is, how did you translate the hard copy reports into XML?
So I'm guessing you're referring to the bodyland ones. Manually. So as probably as Thanassis said yesterday, I used to be a book conservator, so I understood what people wrote in their reports, and I mapped that information then onto the XML schema that I put together. So it was literally just reading through and understanding what they meant, and then transforming that into XML manually. So it was a long process.
Thanks. Okay, next question. Would you continue to use the 3M tool for ongoing data, or would you recommend a more automatic process going forward?
For whom? Well, as I use it as a way to navigate the CDOC, so I always use it. I find it's very great for that. As I said, I prefer to do my own scripts as opposed to the way the 3M works. But as for modeling, I think it's a great tool. Ryan?
I would use it now that I'm very used to it. And one of the things about it, I'm not sure about automation, but basically once you have a mapping that you know works, you just have the mapping file and you run that file in batches on data as you have it, and it transforms that data in a few seconds. So it's not really that it's somewhere that we would, you don't create data in it, but a mapping file can easily be reused to keep regenerating or creating linked data from new XML data that's in the same model.
Great. The next question is about ResearchSpace. So I think we'll save that one until after the next presentation. And then I think we're going to take one more question at this point and then go on to Thanasis's presentation. So the last question we'll take now is, are you considering changing your conservation workflows in the future to more efficiently capture semantic data? Or are you thinking of continuing the current process or mapping? I guess, I don't know if you want to take that, Ryan, since you're affiliated with an institution creating the data.
As I said, we work together to set our digital practices, but I would say one of the things for us is that if we end up having Sinopia CRM profile created in Sinopia that works for us, that it could possibly be a place where where conservators create their documentation, and then it's just made natively as CRM linked data. But the plan for now, an alternative, is that I'm developing a database and web app for us that's tailored to us as an alternative to those Word documents. And we'll just see which works better for us. If we end up doing that XML database, then as we need linked data, I would probably then still use the 3M tool to convert to linked data.
Okay, great. I think we'll leave it there for now. And Thanasis, do you want to start your presentation?
Great. So yeah, it was very nice to hear these two presentations, and thank you both for going through the whole process, and thank you, Ryan, for actually showing how 3M works. I'm going to discuss how the data that were prepared by Ryan and Alberto were then combined and integrated in ResearchSpace, which is a platform that's based on linked data. Now, I think that Dominic Oldman and Cristina Giancristofaro from the British Museum have joined us today. Now, they're both working on the development of ResearchSpace. Dominic is leading it. So I hope that I'm going to do justice to the system as well. So the first thing is that I'm putting up here the link to the system. So this is just a screenshot of the front page of that website. Please copy the link, and if you want to follow while I'm presenting, feel free. It might be a little bit difficult, but also for future reference. Now, this website is hosted by the British Museum as well, so we're really grateful for all the support they have given to the project so far. And the front page, you can see also a few links there that are interesting things to look up when you first visit the pilot website. I'd like to start then by saying why we chose ResearchSpace for the pilot and for link conservation data. And there are a few reasons. The first is, of course, as I mentioned before, that it is based on RDF, on linked data. So it was a system that we could use straight away and start implementing linked data. The other point is that ResearchSpace is designed with a CDOC CRM in mind. Now, it has no limitations. So it doesn't only work with the CDOC CRM, but it has been prepared so that CDOC CRM data, or data that's transformed using the CDOC CRM principles, can work straight away. So that we thought was going to make our life a little bit easier. The other point is, of course, that ResearchSpace is free and open source software, which means it's possible to use without any costs in terms of buying license. And the ResearchSpace team has gone to great extent to keep it free and open source and build a community around it. So that was another important factor. There are little things also that are important for conservation, I think. One of them is, for example, that ResearchSpace includes a vocabulary manager. So if, like I was saying yesterday, we need to provide this global context out of our local data. And instead of having to use a separate system to share one's vocabulary, one could use ResearchSpace to do that as well. So it's sort of saving a little bit on the necessary effort. It also implements a IIIF, and for those who don't know what IIIF is, it's a protocol for making photographs available online. And it also works nicely with a web-based image viewer called Mirador. Now, I'm not doing justice to these things. These are amazing projects that have really transformed research around humanities online. But just as a small flavor of what they do, for example, Mirador is more than just a simple viewer. It allows you to do some basic manipulation on the images, like turning them into grayscale, as you can see in the bottom right corner there. It allows comparisons between images, and this is something that conservators often do when we're looking at older records. You can see here an example from a Bodleian book, before and after treatment. Yeah. The capacity that IIIF provides makes Mirador able to zoom in photographs quite nicely. It's quite an addictive feature, especially now that we have high resolution photographs all over the place. So you can see here how we can compare the headbands on the left, and many other features which I don't have time to go through here. So it works well with images. The other point is about data entry. And in conservation, if we're lucky enough to have a database in our studio, we're used to seeing a form with specific fields and typing in information in these fields, or selecting from drop-down menus and so on. This is the kind of thing that we're used to. And ResearchSpace can do that. Forms can be created easily, so we can carry on doing exactly the same thing as we're doing now. There's no change there. However, there's also another way of producing new data on ResearchSpace. What I mentioned here is mind map. I think they use a different terminology within the ResearchSpace team. But say, for example, we've got an event here, which is a treatment. Yeah, so something is being removed from the book. And we have a specific object, a spatula, that is being used to remove that thing. And say this conforms to the form that people produce documentation with. But if our process is slightly different for the specific book, sometimes we work with objects which are special, and the standard documentation form doesn't do justice to the kind of work we've done. That's always often the case with conservators doing the documentation just because the form is designed the way it is, and not including things that are important, or including them as text in the end. Now, say we wanted to add another thing that was used in this treatment event. Yeah, within ResearchSpace, what we could do is we could add a new entity all through the graphical interface here, and then select how this entity is connected with the main event. So we have a list of possible connections. So I can build my documentation as I go. I don't have to be confined by pre-built forms that do not work all the time. and the options that appear in this list can be customized. Yeah, so like Alberto and Ryan said in the past, you don't need to know everything about the CDOC CRM to do this kind of work. These things can be customized and limited to only the stuff that are interested to you. So I think it's quite a powerful thing for conservators, being able to customize the way that documentation records are built. And this is a slide where I also mentioned Sinopia. And in the linked conservation data project, we are engaging with other systems as well. Arches and Sinopia are two of them. And they're both free and open source systems and designed around the ideas of linked data. And both have very interesting features. And the point is that conservators, we encourage conservators to start experimenting with these different systems, and most importantly, engage with the development teams and communities that build these tools. And we should try and influence as much as we can their development so that these tools also work for conservation. Going back to the pilot now, as Kristen showed in her slide, we had a few research questions that we decided to explore. So one is about techniques, the other one is about material, and the other one is about condition. And so in this process, we tried to interpret these research questions into queries, linked data queries in our data. This is the first one. So this graph shows the frequency that techniques appear around body attachment in our records, and they're divided or grouped based on decades. Yeah, there are two things to note here. One is, of course, that grouping them by decade is a little bit of an arbitrary choice. We could have grouped them differently. Okay, we thought that it was reasonable to group them based on decade. But of course they can be grouped differently. The other point is that if you look at the legend at the top of that chart over there, you will notice things like board slotting and then slotting. And of course over there we're talking about the same thing. It's the same technique. But the idea, what we're trying to show here is that slotting and board slotting are terms that are used locally in the different institutions. We do not have global context for these things. We do not have a vocabulary that describes book conservation techniques. Therefore, there's nothing to match to. There's no way for us to give this global context. We have to keep it local at this stage. The point being, of course, that we need to invest in effort to produce such vocabularies so that we can have global context. You have vocabulary for conservation techniques, or vocabulary for conservation conditions, sorry, for conditions of objects. Anyway, but you can see how through this we can summarize and show possible answers to these research questions. The next one is about material. And we were able to match most of the materials to an external authority file, the Getty Arts and Architectural Thesaurus. So we have global context for those. And what we can do here is we can add one material, say animal glue, and then add another material, say the wheat starch paste. I don't want to show all the materials because there are too many and it doesn't make sense, but I can compare these two if I click search. And I have some data appearing. So one would that there is indication that animal glue used to be more prominent in the early days, and now we have moved on to wheat starch paste. Of course, the data set we've got is not representative of the whole world of board reattachment. It is only representative of the records that we managed to collect. And the tall bar you see on the right-hand side is also because most of the Library of Congress records correspond to the last decade. So it sort of distorts the balance over here. But I hope you can see how we can begin building narratives and arguments supported by actual data. This third query is about condition. And the first table I show here is the condition of boards. No surprises here. The most frequent conditions observed on the dataset are detached and broken boards. That's what's the whole idea. Yeah. If I scroll down, I now have the condition types of other components of books, associated components. Yeah. And again, it is not a surprise to see that we have damaged text blocks and damaged sewing structures as the top types of condition appearing in that table, and then further down, torn hinges and broken sewing supports. But now we can correlate the condition of the detached board with other conditions on the book. So that again gives you a flavor of the kind of interrogation we can do on the data to answer broader research questions. This slide is the background. Yeah, it's a little bit of code over here just to show you that the table that you've just seen is the result of a query on the data. And every time I refresh that page, I get a fresh chart based on the live data. So when new data comes in, this chart will change. Our understanding of what the conditions are will change. Now, what I'm showing here is a combination of free text and real data. So the chart that you see at the bottom is live data. It changes as new data is added to the system. The top bit is text. So through the text, what I'm doing is that I'm building a narrative, I'm building an argument about the techniques of board reattachment over the last 50 years. And then I can support this argument with data coming out of my database. So this makes the arguments a lot stronger. Now, as part of the pilot, and I think both Alberto and Ryan mentioned that, Alberto and Ryan produced 2 conservation reports. Now, what these are is replicating as part of our records, but also enriching these reports with real data from the database. So over here, for example, we've got an event of a removal of adhesive from the spine. And before that, we have some narrative explaining why that would be a good idea. Yeah. So again, supported based on the actual data. And over here we have it's more complex, but if we take the time to look at each individual box, we will see that this is a partial resewn of a sewing structure, and the text that follows explains why this would be a better idea than just taking everything apart. Yeah. So it's using these reports and showing how they can be enriched. We still keep that format that is well known to conservators, but enriching it with actual data. I'm going to show now a few examples of records that we introduced in the system. And these are records, or rather the appearance of these records has not been customized. We just dumped the data on ResearchSpace, and the way that these things are shown by default worked. Yeah. So we have an example of a record of a book here. Nice photographs shown at the top. If I scroll down, you will see that there's a column on the left, which are all the connections, all the CRM properties, yeah, and then corresponding to other items in the database. So if I look at is composed of down here, and I'm not sure if you can see my mouse, my pointer, that corresponds to all the components for which we have records in the database. If I click on one of them, it'll take me to a new page explaining what this component is and so on. This is an example of a treatment, a modification event, a treatment where a technique was used, the technique was flattening, and the text block of that book was modified. So by default, the team who built ResearchSpace thought, oh, these three things are useful things to have when you're describing a treatment event. If I want to extend that, I can customize it fully. I can add more details. When I see a treatment event, I can add more details. But I'm just showing you the default over here to see that it does work. This is an example from the National Archives where we have the right board of a book with two conditions, detached and broken. And this is another example of a modification event, a treatment, the hinging that has modified the text block. So, so the idea is that we can browse linked data records click by click, step by step, if we want to explore them that way. But we can also summarize them and build bigger narratives based on these records. Now, another interesting tool enabled by linked data practices is structured search. And I'm sure that Dominic and Christina would like to demonstrate this instead of me, as this is very much a work in progress at the moment. But I'll just give you again a flavor of what's possible. Because our data is based on the underlying CRM structure, we can use that structure to search. So in this tool over here, I can start with a man-made object, and I can select to connect it to type, and the type of that thing is book, and therefore I get all the results that are on the database, man-made objects of type book, all the books then. That's one way of doing it. Now, this is not predefined. I built the query as I was going. The next one is an example with a modification event related, that's a treatment, so a treatment related to a physical thing, a man-made thing, and I can further filter down the man-made thing, not any man-made thing, but those that have specific type book. So what this query gives me is all the treatment events that have happened on books in my database, and so on. So just an indication of, I mean, that every single entity and every single property in the CRM can be used to build this structured query. So it's a very powerful tool that we need to explore more. The last query I'm going to show you is in relation to the workshop that some of you will be able to follow after this presentation. And I'm just showing here that we can work with linked data no matter how detailed our records are. We may choose to simply list the books that had a treatment at some point, or list the books and the date of the treatment, if we have that information, or the books, the date, and maybe the materials used, if we have that information, if we think this information is useful. So the level of detail is irrelevant in a way that the technology works. The technology can work with any level of detail. The question, of course, is, and this is where we have the discussion around signposting queries, what is useful to model if we don't have time to model everything? I'm going to finish this presentation now. I hope this gave you an idea of how we've been spending our time on linked data with this project. Please have a look at the pilot website, explore it yourselves, and return to us with some feedback. We'll be very grateful for that. And you know, finally, on behalf of Kristen and myself, would like to thank the pilot working group from Stanford, the Bodleian Library, the Library of Congress, and the National Archives. They've really given a lot of volunteering time to this project. We would also like to thank, of course, the ResearchSpace team for their continuous support and responding to our queries very quickly. Particular thanks to Alberto and Ryan, who I know very well have spent many extra hours on this exploration of linked data for the project. And finally to Bridget, who has been the communication link among us and has been keeping an eye on our progress. And I'd like to send a virtual clap to everyone. Thank you.
Great. Thank you for the presentation. Let's continue. We have time for a few more questions before we wrap up the webinar and move over to the modeling workshop. Maybe we could start off with the first question from the last time, which is our, if it wasn't already answered, is our ResearchSpace instance based on the free code?
Yeah, and perhaps Kristen or Christina, sorry, or Dominic will correct me, but I think it is basically the code that you can get from the ResearchSpace repository. It's hosted with British Museum, so I guess if any fixes come out, that's the first place where the fixes are applied, but it is that code, yeah.
Okay, our next question is it possible to expect from this marvelous project that mapping for a standard conservation report could be prepared and become available to create a standard conservation database?
I think it is nice if we limit our options so that at least we have a smaller subset of things to worry about. But I do not think we can get to the point where we say, okay, this is it, people, use this. The idea of having a standard documentation system is a little bit difficult, I think, because each institution, each researcher, each conservator has different interests. Inevitably, they will want to focus on something else than what somebody else wants to focus. So to provide one way, one sort of database to do it, one documentation system would be difficult. I think what we're trying to do is the next closest step here. So make sure that all of these things, no matter how diverse they are, can play together.
From a CRM SIG's point of view, we believe that it is the antithesis of what we want in any discipline to standardize on one database and one database structure, because it fossilizes whichever discipline or subdiscipline you're working with. So the real ethos behind the CDOC CRM is to allow us to blend different data sources working at different levels of granularity with different special interests and deep holes that people want to dive into for their particular research, and allow it all to be used together. Me particularly, am deeply opposed to the idea of a single database structure to conquer the world. It doesn't work. We've proved that over the last 50 years. Every time, you know, I've tried to not do that for 30 odd years and succeeded quite well. But it's use standards to help you, not to straitjacket you.
I think the semantic data dream here is that the internet sort of becomes almost a database in itself, but we just sort of form the database as we need it, since our data is semantically structured. But one thing I would say for the conservation community is that it's probably more important to think about data standards, not necessarily a shared database, but the standards in the way that everyone is capturing their data. Because in order to get to linked data, you still need to have some structure. And there are so many different ways that people are capturing their data. Whereas in parallel fields, like for descriptive catalogers, there are a lot more guidelines, metadata standards in place that aren't necessarily to the field specific, but that at least give everyone guidance for what they might want to capture and how they maintain it. And those things also link to models that, we could have not necessarily one standard model, but maybe models that are flexible enough for people to turn to when they're planning their data.
Great, thanks. The next question is, how does the Sinopia system compare with ResearchSpace? Are they completely different, or is there overlap? Sinopia is really, to the best of my understanding, more a cataloging tool. It doesn't have the environment and the visualization possibilities that ResearchSpace has. So I think it might be more like the fourth tool than it would be, maybe not even that, but it doesn't have the kind of visual potential and that ResearchSpace has.
No.
Ryan, if you want to leap in and.
Yeah, it's very much like if you work at a museum and have been dealing with your collection management software there, or if you have ever seen a library cataloger, it is like that, just that it benefits from the linked data context in that it's very modular. So people, rather than having a rigid interface where people are putting this value in that box and this value in that box, they can create as much data as they need. But it is very much a cataloging system.
Okay. Then the last two questions, are there any shared public templates for spreadsheets for recording structured data to use as a starting point?
Well, we certainly have a couple of spreadsheets for vocabularies. So people who want to start looking at the vocabularies as documentation, these are published as part of the guidelines for terminology. But for actual conservation records, we haven't got to that point, although I suspect that the schema, Alberto, could be shared as a potential way of doing it, but it's going to be very specific to board reattachment.
Well, I did model the rest of the stuff, not just the board attachment. It's on GitHub, as I said. I would change a few things, but it's there as a model for sure. It's freely available on GitHub.
And for our version, I just tried to abstract everything as much as possible because I knew that it would need to be extended to the rest of our data. So it works for board reattachments, but it's sort of modular, so it can apply to everything. Of course, I would like to talk to Alberto and what he mentioned about adjustments, because I found a lot of the same issues as I was doing the mapping in 3M.
Great. And then the final question is, does the link conservation data have a plan to extend to other fields such as paintings, objects, and textiles?
Of course, we've never started the project as a book conservation project only. Clearly, the fact that we have 4 of the largest libraries in the consortium has helped, and people have been extremely supportive in the various book conservation labs. So that's why we decided to do the pilot on that. But nothing that we've done for the pilot isn't applicable to other domains. I mean, we can follow exactly the same process for any type of object, and we welcome proposals from people if they want to try out the technology and include some new type of object. That would be fantastic and very very promising. Yeah.
I saw that George had his hand raised up. George, do you want to? I can allow you to talk if you have a comment.
Am I unmuted?
Yes.
Am I? Oh, great, thank you. I just want to chime in on the question about sort of cataloging standards or guides or what have you, and just to say that I think that this signposting exercise can be part of that sort of thing. That LCD is this network that allows people to talk beyond their institutional confines about the information structures, and if we can sort of, use it as a platform to identify these things that people, identify as needs, as wants, and so on, that abstract list of models, of things to be documented and the information about those things that are crucial, is independent of any information system, but you could make the connection to, okay, we record that in our database here. And so that would be a way to eventually simplify this relatively complex process of semantic data management that you've been seeing some pieces of, so that if we decide, there are these 4 kinds of things that conservators definitely want to be able to share information about, and there are 5 fields for each of those as a start, that it would be interesting to be able to share, then that limits the problem to something sensible, because we can create a CDOC CRM standard mapping, the LCD network can, that is, which will be the way to go forward. And then it's more about connecting to the abstract fields, as it were, of these abstract cataloging guides. And then once you've made that connection, then the CDOC CRM kind of happens automatically for you, and you can avoid learning semantics if you don't want to, basically.
Okay, great. Well, I think that's all of the questions that we had in the Q&A. So I will wrap up, and it's 8:15, which is a good time to wrap it up. And we'll thank you very much to everyone who attended today. We really appreciate your interest, and we hope for your continuing involvement.